Good morning, everyone. So I'm trying to fix the YouTube live streaming for others to join, those that want to join via the YouTube. So Good morning, everyone. So I'm trying to fix the YouTube live streaming for others to join, those that want to join via the YouTube. So Good morning, everyone. So I'm trying to fix the live streaming the YouTube channel. Okay. So I can. So good morning, everyone. I am surprised that it's just 7 students that joined the class. And I actually asked the subdeans to share the Zoom link. So I wouldn't know what happened. Maybe they forgot. I don't know. But nonetheless, this is 10 minutes past 11. We have to still move on with the class. Like I mentioned in the last class, the foundation students are writing exams at a DLI, so there's no way we can have physical teaching. So we'll continue. I hope you can see my screen. I'm sharing a screen with you. Let me reshare. So can you see my screen? The PowerPoint slide showing the diagram of the world. Are the students there? Hello. You can unmute yourself to talk. Are you there?
Yes, sir.
Okay, so thank you. So we'll commence the class now. So just like I mentioned in the last class where we discussed about gravitational force. So we'll also continue from where we stopped the last class to actually look at the effect of gravity. So a little revision on what was taught in the last class, and so we can move on from there. So if the force of gravity is being exerted on objects on Earth, what is the origin of that force? So ab initio, Newton's realization was that the force must come from the Earth. That was what Isaac Newton initially thought. So he further realized that this force must be what keeps the moon in its orbit. So we found out that the moon, the earth, the sun, all terrestrial materials, they maintain their orbit and they continue in that, rotating, revolving at the same time. So that was what amazed Newton. However, he later on observed that the gravitational force that is exerted on us is 1/2 of a third, law. So the earth exerts a downward force on you and you exert an upward force on the earth. You are sitting down in your room, you are sitting down in the class, the earth's pull on you is acting on you downward. Likewise, you are also, for every action, Newton's third law of motion, there's always a reaction. So this is the action and this is the reaction. When there is such a disparity in the masses, the reaction force is undetectable. But for bodies more equal in mass, it can be significant. And this is an exact thing that we are seeing here. We have the moon, gravitational force exerted on the moon by the earth. That is it. While gravitational force exerted on earth by the moon. So the moon is also doing the same thing. So that is what we see that is obtainable with the terrestrial materials as well as objects on the surface of the earth. So there's always that gravitational force of attraction between them. And finally, it was then decided that the law of gravitation is given by this. So M1, M2 are the masses in question that are interacting, and R is the distance of separation, while your G, which we refer to as the gravitational constant, we refer to that as our gravitational constant. That G is given by this. So that's the Newton's gravitational law of attraction. Thereafter, it was then the gravitational constant was then calculated using this experiment, which we refer to as the Cavendish experiment, So thereafter, we last week, Thursday, we were made to understand that the weight, that is the earth's pull on every object, is given as mg, which is also like a force acting on the object, acting on a specific mass. We can then relate that because it's also a force. So we can relate that to the Newton's law of gravitation between two objects. And with that, we were able to calculate our G. That's our acceleration due to gravity with respect to every mass. Every mass in motion under gravity, we can calculate that. So here we are using the Earth as an example. The gravitational constant is there, the mass of the Earth, and the radius of the Earth is as well there. So with that, we were able to deduce the mass of the Earth, and the mass of the Earth is given as this, approximately 6 times 10 raised to power 24 kilograms. Any questions so far? If you have questions, unmute yourself to ask questions. If you have questions, unmute yourself to ask questions. So let me continue. So the acceleration due to gravity varies over the Earth's surface due to altitude, local geology, and the shape of the Earth, which is not quite spherical. So by the time you're from, it varies with altitude. That means if you move from one space to another space, you find that the G differs. Even between here and Abuja, or between here and Sokoto or whatever, the G will vary slightly. To vary slightly. So, and these are the various G's with various locations. Now we move on to this. When we discuss about satellites, satellites are communication equipment that assist with one. It can assist with surveillance. It can assist with telecommunication. And it can also assist with broadcasting. So usually it is the launching of the satellite that makes this very, very simple and very, very easy. Now, in terms of all these satellites that have been launched up are launched in such a way that when they are launched with certain velocities. But before they are launched with certain velocities, the first thing that is carried out is to first of all attach it to, usually you attach to some rockets. So it's the rockets that will take them out of the vicinity of the Earth, as we are seeing here. So first of all, they are taken to what is referred to as parking orbit. They are taken to where it's referred to as parking orbit temporarily. And from the using a spacecraft. So thereafter, from here, they are then moved from the parking orbit, where they stay temporarily, to a geostationary orbit. They are then taken to a geostationary orbit, where they stay for several years, where the satellite will stay for several years. Now, when the satellites stay there, they have the ability of allowing us to carry out surveys, allowing telecoms to operate, allowing for broadcasting. So all these are necessary and they stay there for some time. And usually what happens, because they themselves, the satellite themselves will be rotating with respect to the Earth. And what happens as they are rotating, that means you have what is called the centripetal force acting on them. And that will now be equal to the force of attraction between the Earth and satellite. So we can then have our mv squared divided by r, which is the force, centripetal force, to be equal to m divided by r squared. So from here now, we can make G the subject, the V, the subject of the formula. If we make V the subject of the formula from this relationship, if we make V the subject of the formula, that means we'll have V is equal to square root of 2gm divided by R. This is the radius of the earth, and this is the mass of the earth. Thereafter, this can further be reduced to 2gr. The acceleration due to gravity and this, I made mention of this in the last class. And this V is what we refer to as escape velocity. It depends on the orbit you want the satellite to stay. And for how long do you want the satellite to tarry? Is it for 20 years? Is it for 15 years? Is it for 10 years? Is it for 50 years? It depends. So depending on that, that is what determines the V. And this V in correlation, we all know that under circular motion, our V is equal to 2 pi R over T over the period. 2 pi R over T. That is the period. 2 pi R over T. That is the period. So in place of your T now, if you now put that there now, from here, from what we have here, we can invariably say that V square, we can invariably say that our V square will then be equal to GM E over R, at the same time equals to GE RE square over the distance between them. That's the radius of the earth. So when we now do this, in place of our V now, we now put 2 pi R over T. Finally, we'll be able to have the period. And when we talk about the period will eventually give us 4 pi square R cubed divided by GE, that acceleration due to gravity on the earth, and the radius of the earth. This is what we have. The R is the distance between the earth and the satellite. So this period now gives us the time the satellite is going to tarry in space. It will surely give us the time it will tarry in space. That's the period. So, and that's why at times you will receive announcement that some certain satellites are falling back to the surface of the earth when that period is completed. When that period is completed, they come back to the surface of the earth and they are received. Maybe additional things are added to it, then is relaunched back into the orbit again. So depending on what you want to do, that determines the speed. So the velocity you give to it determines so many things. Velocity given to it determines so many things about the satellite being launched. So escape velocity is what takes it out of the Earth's surface. Initially, it stays on the parking orbit before it's now taken to a geostationary orbit where it stays for several years. Any question? You can unmute yourself to ask questions. Unmute yourself to ask questions.
Why does the satellite fall back down?
What is what?
Why does the satellite fall down? Why can't it just stay there?
Why can't it just stay there for long?
Stay up since you've already launched it.
For several years, no. Because with technology, technology is advancing. I hope you understand what I'm trying to say. As you launch one satellite, newer satellites are being developed. And when they are being developed, you need to recall the other one. Or it might be that one that is in the orbit, you want to add some other things to it. And it's not all the time you have to go to space as human. It's not all the time. So depending on the velocity you give, that will determine the period it's going to stay there. To stay for 50 years. For example, even the US, they have a very good satellite, even Russia. And at times, in terms of what US uses for their military and whatever, they get information from Russia. They depend on Russia intelligence to act. Or Russia has launched very good satellites that are in space. So those satellites are able to harvest information all over the world. So if it stays there for several years, it will be difficult for you to give additional facility to the satellite. So at times it needs to come back for maintenance and all whatnot. So it cannot stay there for long. As it's coming back, another one would have been launched and stay there in that specific orbit. Why that one will fall? So when they launched it, they usually know when it will come back. They are sure of when it will come back. So it will lose that orbit, and it will not continue in that orbit. So it comes back, and as it's coming, before the period of expiration, another one would have been launched. Another one would have been launched to take care, maybe with better facilities. And when that returns, either if they still want to deploy it, they can put some other facilities and redeploy back. I hope it is clear. So any other question? Any other question? So in the absence of questions, then we can move on. Now, the satellite is kept in orbit by its speed, just like I said. And that is the escape velocity, which is usually given as v is equal to square root of 2gr, or at times we might give it in terms of the might be in terms of v is equal to square root of 2 gravitational constant, the mass of the Earth divided by the radius of the Earth. So this is what we have. Either of these two, it will give us. So the speed is what determines which of the orbit it stays. So it is continually falling, but the Earth curves from underneath it. So this is the satellite, this one. So the Earth curves from underneath because the Earth rotates. So the Earth continues to rotate in that manner, and the satellite is also rotating in its own orbit as well around the Earth. So without gravity, we can see it is straight, while the satellite with gravity, you can see it will bend and move around the surface of the Earth. So there's always an interaction, a force of gravity between the Earth and the satellite. So this is another concept when we discuss about elevator. And under elevator, what we really want to achieve is that we can have a situation where there is weightlessness. And when we talk about weightlessness, this is a situation where the weight of the passengers in the elevator becomes 0. It becomes 0. And how does it become 0? If we look at the elevator, attached to the elevator is a scale. The woman within the elevator is an observer, trying to look at what is happening within the elevator. So you now have an object on to a spring balance. It's on to a spring balance, and the various things were carried out. 1, the elevator moves up, accelerating up. The elevator is accelerating up. When the elevator accelerates up, we have different kinds of reaction. When the elevator moves up, you have different kind of reaction. The mass mg of this acts downwards. Why? You find the reaction W moving up. You have the force mg acting downwards. So the same thing is observed here. Now, basically, there's a reaction. When the elevator is moving up, you will have a situation where you have m is equal to a plus g. You have a situation where you have m is equal to a plus g. When the elevator is accelerating up, this is what you have. So the passenger or the object in the elevator will feel heavier. Even if you put a weighing scale here, and this woman is standing on a weighing scale, if she's 60 kilograms and the elevator is accelerating up, she will observe that instead of 60 kg, her mass is going to increase. The total weight will surely increase. Now, the mass, no, not the mass, sorry, the weight. The weight will surely increase because it is accelerating upwards. But if it is accelerating, but now moving at, please excuse me. So sorry. Now, if it is accelerating upwards, the reaction, the weight is going to increase. But however, if the elevator now slows down on its way up, because when it wants to stop at a particular floor, you find out that it slows down to stop at that floor. At that point in time, the R will be equal to M. That will be G minus A at that point in time. You have G minus A. That is what you have at that point. Also, if the elevator is also coming down, if it is coming down, you will also observe the same thing as this. And then you feel lighter. You feel lighter in the elevator. But however, if the elevator now has an acceleration that is equal to the acceleration due to gravity under which it is acting, So you have your R to be equal to what? 0. At that point, when A is equal to what? A is equal to G. When A is equal to G, your R becomes 0. And at that point in time, we have what is referred to as weightlessness. We have what is referred to as weightlessness. That is what you have. You have what is referred to as weightlessness. So any question? And this is what you have here. It's as if the effect of gravity is not on it. And one of the means by which you can have A to be equal to G where weightlessness occurs is when the string attached to the elevator breaks by accident. That's a free fall. That's a free fall. So any object under free fall, the A is always equal to G. It feels weightless. It feels weightless. So any question? Any question? You can unmute yourself to ask questions. So we can see examples of where we can have all this. This is a woman doing acrobatics. This is another man skating on ice. You see them jumping. And you can also find weightlessness on the surface of the earth. Though it's temporarily, but the gravitational force still exists. It's a temporary phenomenon. It's not something that is continuous. It's something that is temporary when A is equal to G. W will be equal to 0. That is what you have. That is what you have there. That is what you have. So any question? Any question? Unmute yourself. Any question? So in the absence of questions, we then have the Kepler's law, which we treated last week. There are 3 laws. One is that the orbit of each planet is an ellipse. The orbit of each planet, this is the sun. Let's assume this planet Earth is an ellipse. We can see the shape with the sun at one focus. The sun stays at one focus to it. So, and this is what we have. The sun remains where it is, while the earth moves around the sun. The second one, that an imaginary line drawn from each planet to the sun sweeps equal interval. This planet 1, planet 2, maybe Earth, Mars, Jupiter, and the Neptune. You observe that each of them, when they move around the sun, they sweep out equal areas in equal times. Equal area at equal times. That is the second law of Kepler's. Why the third one, that is what describes the period with the radius being covered. And last week, we saw that the period will be square, while the period or the distance will be cubed. That was what we saw in the last class, the relationship between them. So as a result of all this, we've been able to observe that modern physics, and one of the things that we treated in the last class is that when objects, for example, you have the Earth, you have the radius of the Earth. If objects are here, if you remember the problems we solved, you have plus h. You have plus h if it is acting outside the Earth. So you cannot use the radius of the Earth at this time. It has to be plus that distance from the Earth, surface of the Earth, to where the object lies outside the Earth. But if the object is on the surface of the earth, our r will be the radius of the earth. So that will be interaction between the earth and the object. But if it is far away, above, then there's also an additional h. So instead of having f is equal to g, m1, m2 over r squared, that will be r squared plus h squared. The additional distance is above. So that's what we have. So I haven't gone through this, all this last week, Thursday, and now the remaining part. What questions do you have? We have discussed about the Newton's gravitational law. We have discussed about the Kepler's law, the three laws. We have discussed about weightlessness. We have discussed about geosynchronous orbit. We have discussed about the escape velocity. We have discussed about finding G. Another thing we discussed in the last class was the gravitational potential. Gravitational potential, which is given as V is equal to minus Gm, and the other mass over R. His own is not R squared, or potential is just a single, the distance is not squared. And it's always minus because it is the work done in moving a unit mass from infinity to a specific point. So because as you are doing that, you are acting against gravity, that's why you have the minus sign. So if you have questions, please unmute yourselves. If you have questions, unmute yourselves. Any question?
Good morning,
Any
sir.
question? Yes?
Good morning, sir.
Good
Now
morning.
to ask that if someone inside the elevator and it is weightlessness, will that person experience it by himself or herself?
Yes, the person will experience it. The person feels as if is maybe like a tissue paper in the elevator.
Thank you, sir. Thank you, sir.
The person will feel like this. Or you have a mountain climber having a rope tied to the cliff top and the rope caught all of a sudden. The person going down, he feels like a tissue paper, like a leaf falling from a tree. Because the weight is zero, though it's temporary at that point
Thank
in
you, sir.
time. Okay. Any other question? Any other question?
Hello, sir. I have another question, sir.
Okay, what's your question?
Please, sir, are we having tests or we are just going to the submit our assignment?
So you'll be
for the
having
test?
tests. The assignment given to you. You also have some online tests, and that will be coming up next week. Details will be
All right,
sent
sir.
to you through the sub-days.
All right, sir. Thank you, sir.
Sent to you through the sub-days. So you have the guidelines on how to write the test. The tests come up during the lecture-free week. So you will have the question. Details will be sent to you next week. Aside from the test, the assignment given to you that you are submitting. So any other question? So in the absence of questions, I wish to inform you that the lectures for this semester for PHY-CM 101 General Physics 1 has come to an end. So I wish you all the best.
He said our test
Your
will be
test and the examination. And the examination. So I wish you all the best. Ensure you have good internet facility for your test. Please ensure you have, even if you have, go to a location where you have good reception. It's very important. Entertainment of my network logged me out. There's a way to check if it's the network. Some of you will create a lot of lies and all whatnot. So some people are raising up their hands. You can omit yourself. Adedeji, Maria.
Yes,
what
sir.
do you have?
Good
Okay.
afternoon, sir. So
Good
we're
afternoon.
having GST next week for life science.
GST exam.
Yes.
Next week, Monday, sir.
Next week, Monday.
Yes, sir.
It might not be Monday that your test will come up. Even for the GST, there's always a duration. Currently, you don't know the time you write the test and the day. Do you know it? No.
No, sir.
So if you're having GST on Monday, the GST will not take. Usually what GST does is to open it up for the entire day or for some period. Even the test you are having for your specific group, it will open up a specific time for you. All those details will be given. So there's no way it will clash. Each of them, they have durations. So clashes will not occur. Even if they occur, you still have time to write the test. I hope it's
Thank you,
clear.
sir. Yes, sir.
Okay. Any other person?
Yes, sir. Please, when is the test? The PHY test.
The PHY test, information will be given to you. Memo has been sent to CITS, but we need to confirm those dates first from CITS. Everything will be sent to you before the week runs out. Because it's not just physics alone that will be writing the test. Other faculties too in the university will also be having their own test as well. So we need to be sure that day is free for us. But the intention is to have both PHY-CM 101 and 102 the same day. That's the intention. We'll be having them the same, but at different intervals. Maybe it might be 101 that will come first within 5 hours or 6, while the 102 will come also within 6 hours also. I hope it is clear. Yes.
Please, how can we get the slides or give
do you need the slide? Everything has been taught is in the textbook. Or you look for some other textbook. The slides are teaching aids. It's not study materials. Slides are prepared by lecturers as teaching aids. And that's why the recordings, the YouTube channel, if you go to the YouTube channel, you can listen to it all over again and again. I hope it is clear.
Yes, sir.
Yes, sir.
The YouTube channel has been shared with the subdeans. But however, I can copy now and paste there for you to also view it. Let me see. Okay. Let me just copy and paste so that I display for some time and you can always so those of you that want to take screenshot or you want to snap, you can do that. For today, this is what you have. So that's the YouTube channel. Yeah. That's the YouTube channel that you have here. So that's that. For last week, so let me see if it's the same thing. For Thursday's zone. So you can listen to it and in conjunction with the textbook, you are good to go. For last week, let's see. So that is for last week. And this is for today. So for today, you have this. So these are the YouTube channels. This is for the first class, the upper one, and this is for the second class. This is for the second class. So I think with what we have here now, you can go back and listen to the classes. and also go through your text. You have enough questions there to solve. The number of questions you have there so this is one. You have about 23 questions in the textbook that's been specifically designed for both 101 and 102. You have about 23 questions. So I haven't gone through that text solving those problems. You shouldn't have any problem with gravitation. Any other question? So in the absence of questions, I wish you all the best in your forthcoming exams. And
Thank you, sir. I really do, sir.
so see you next week for the
about
test.
conflict.
What is it? Someone said he has complaints.
Maybe 11 o'clock.
Maybe what? What did you say? I can't hear you.
Not sir, not sir.
Okay. Thank you very much. So I'll end the class now. So details of the test will be sent to you. Thanks for the. Yes? Are you all booting like computers? You are just saying sir, 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 and you are not talking.
No, I said thank you, sir.
Okay. My pleasure. Thank you very much. What is it?